Okay, so I am Sababu Shakabar Shango. I've been in education for 21 plus years. I was a mathematics and computer science instructor, received a BA in mathematics and French from Morehouse College, and a Master's of Arts in Teaching from Emory University. I was trying to think ahead. And so, I always grew up with the African proverb, he who learns teaches. So it's an Ethiopian proverb, and that's what I believe. So um, right now, I'm a Constellations Fellow trying to help the teachers teach the students so the students can learn. Boom, shakalaka.
Boom, shakalaka. All right, thank you, Babu. I am Terry Foster. I am also a Constellations Fellow. I have a bachelor's in CIS and a master's in instructional technology. Prior to working in education, I've been in education for about 8 years, not 8 to 9 years, 9 years now. Prior to doing that, I was in the industry. I did some programming, some project management, working in healthcare, and also in finance. I love teaching. It is my passion. I do not regret leaving the industry, not one bit. And I love working with the Constellations Fellows team that we have. We have a very unique and diverse, dynamic team. And so I look forward to assisting you all and working with some of you all in the future as well.
So some housekeeping duties. Don't forget to fill out the attendance form or attendance survey. That's near the top of the chat, so you can get your credit for this session. If you need an attendance certificate, you may send inquiries to GT Constellations at GATech or GATECH.edu for that. Also, if you're posting to social media, which we're going to ask you during this presentation, please take pictures, take screenshots, post, but also tag us with the hashtag Constellation Summit, and that's already in the chat window as well. So we do appreciate you coming here, whether you're new to computer science teaching or a veteran, please stick around. We could use your help also.
Yes, we're going to have an interactive session toward the end where we're going to allow you to provide some code and kind of demonstrate or kind of utilize the the physical computing device that we have for you today for those who do not have that device readily available for them at home. So without further ado, I'm going to let Sababu take over his part of the presentation.
All right, I'll just put in the email. Okay, so let's do this. All right. Oh, don't forget, the link to the presentation is in the chat as well. It's the SharePoint. Well, which one is it? I think that's the one okay, pinned at the top. Okay, that's pinned at the top. The presentation is pinned at the top. Let's do this. So I'm going to be switching back between that presentation and document screen, so forth and so on. Let me just kind of be all around. All right. And just kind of, let us know if you're good, if you see stuff, what have you. Okay, can y'all see that? All right, good. So welcome, this is ArRay, a drop of golden some, and then some, as you'll see. What we're going to do today, and just to let you know, if you have, this is kind of like a cooking show. If you're trying to create a recipe and cook while you're watching the show on TV, we want you to do that with us. So if you have some containers, if you bought your containers, great. Go ahead and tell us, well, what containers do you have that's going to represent your array? You brought some elements, put in the chat. What elements did you bring that's going to that you're going to use for this demonstration? So we want you to kind of do this along with us. And if we're going too fast, apologize. But all of the sessions are being recorded, and they'll be available on our YouTube channel after the summit. So you'll be able to kind of go back and do that as well. You can also, my partner, Terry, the veteran, the lead, He'll be manning the chat. So if you have any questions, feel free to put those in the chat as well. So
I'm just a guy.
So go ahead and list. What container did you bring? What elements did you bring? And and we'll go ahead and deal with that. But some of the things we're going to cover today, why do we even want to learn about arrays? We do some tasks for the unplugged activity to get the students used to vocabulary and being able to identify different characteristics of arrays. Standards and alignment with like CSTA, the College Board, CTAE, so forth and so on. Array resources, physical computing activity, resources for the classroom, to help get some funds or equipment or materials, and then how to stay in touch with us. Okay, so some things, we say, okay, well, why are we kind of learning about arrays anyway? All right, well, do you collect anything? One example that somebody gave me was, well, when you come to school, okay, what do you bring? You got a book bag? What's in it? A whole lot of stuff. But what about trying to bring all that stuff to school without the book bag? Okay, that's Mr. Cedric Stallworth. I got that I stole that from him. Okay, so, really. So arrays are very, very useful. If you collect anything, like what do you collect? What kind of container do you use for your collection? How do you organize it? If you organize it in any way, is it sorted in any way? What is the procedure for finding certain items in your collection? How do you distinguish one collection from another? And if you can't see this, like I said, I did put a link to the slides, so you can kind of enlarge it a little bit. And don't forget, to enlarge the presentation, just double click on the window. Okay. So at this point, when you get to arrays or data structures, you should have kind of covered some other basic concepts with computer science, such as like variables and things like that. So, if you wanted to store, let's say, some values or what have you, we would go ahead and create a variable. If you want to store 10 values, we go ahead and create 10 variables and everything. And every time we wanted to use them, we would have to call out the names of those 10 different variables, each and every time. But there's an easier way. So with arrays or array lists, or other, hash maps, other type of collections and lists and things like that, we're going to just focus on arrays today. You can just have one name for your container and just call that name up. And if you want the individual elements, all you do is identify the specific index. And we're going to get into those definitions as well during this activity. Did anybody put in, somebody got a muffin pan? Okay, I see. I'm trying to read the chat as well. Good. Jars and peanuts. Excellent, excellent, excellent. Pillbox, I see. Okay, some excellent examples. Yeah, an array. What is an array? Array is a data structure and reference object, which allows us to keep a collection of elements of the same data type. This means we can name the collection with one name and just access it via the index, or another vocabulary word you might hear is subscript. And this only reserves one location in the memory, so you don't have to go hopping around looking for different locations. There is a difference, of course, with the different languages and scripts when you're dealing with arrays. For example, in JavaScript, the array can be dynamic, meaning it can grow in size, it can shrink in size, so forth and so on. In Java, not so much. Once you declare the cardinality or the length or the number of elements in that array, it just kind of sticks there. We do have a way to circumvent that with another type of collection, which is using array lists, but that's for another discussion. Okay, now with you have your container, you have your elements, take pictures and everything, post it, hashtag Constellation Summit. We're going to also, if you have something to write with, so if you have a dry erase board, a piece of paper, some sticky notes, those will come in handy as well. And we're going to go ahead and accomplish some tasks. Okay, the first thing we want to introduce to the students is being able to declare and instantiate an array. Okay, so I'm gonna kind of switch to my document cam as we go through some of these activities. So you can see I'm doing this as well. Now in the slide presentation, you're gonna have different values or what have you, but that's just there for a sample, you know. Okay, so I have my Mancala board, and we're only going to use one row right now. So
is that your Eagles Super Bowl ring you have on?
I wish I did have an Eagles Super Bowl ring. No, it's my Morehouse class of 1995 ring. Nice. Right there. Okay, so I have a Mancala board, which is a game board. I actually have some other ones that I have a tic-tac-toe board, so if you want to use that. I even have a little yogurt, box that holds yogurt container. So checkerboard, a whole lot of different things that can represent. Go ahead and put in the chat some things, in real life that you can make that connection that could represent an array.
We got parking, we got Mancala boards, playlists from Richard, of course.
Playlist, nice.
Mm-hmm. Box of writing instruments, baby food jars and peanuts. Someone just had a baby.
All right, so if you can see my screen, hopefully you see a few stones. I then went ahead and just put stones in there as my counters. You don't have to use counters. If you have sticky notes, you can use character literals or string literals or anything like that. Add your elements, so you can just kind of write down on a piece of paper as well. Okay, so we went ahead and randomly put some elements in our array, and I'm looking for my marker. The next thing we want to do is go ahead and just name your array. So what are you going to use to reference? So when you invoke or call up your array. Okay, I'm gonna just call mine stone. Call it stars. So just somewhere on your piece of paper, dry erase board, write down the name of your array, which is going to be very important because we're going to need to use it. Okay. And so the next direction is to, declaring. So declaring, if you look on the slides, if you have that open as well, means to create the array's reference. And instantiating, which is another vocabulary word, means to go ahead and allocate a location in memory, or you can fill it up with some elements. Fill in those arrays with some elements. Okay. All right. So now, how do we declare an array? Well, to declare an array, the first thing is you have to know what your data type is. So the data type of your elements. My elements are integers. So then I will use int. So I would declare with the keyword int for integers. If you had decimals or floating point decimals, you would declare with the word double. If you had strings, you would declare with the word string with a capital S. Okay, a Boolean, no bullying allowed in class, but Boolean is allowed. So you could do lowercase b boolean or what have you. The other thing is to indicate that it is an array, you want to use your grouping symbol, which I'm going to refer to them as brackets. Okay. So you have your data type, that's going to be your elements in your array. You have your brackets that represents it is going to be an array. And then you have the name of your array. Okay. So that's just the declaration part. All right. The next thing I asked you to do was go ahead and instantiate it. So go ahead and list or assign the entities, the positions, what those values or elements are. And so on my next line, I'm going to put stones is going to be assigned. I'm going to use an initializer list. I'm going to show you a way in general how to do it. Okay. And here I have what my first element. I see I have 2 stones. My next position, 2, 4, 6. I see I have 6 stones. That's 6. The next position, I have 1 stone. I have 3 stones, 1 stone. I think that's 5. Okay. So I've declared my array. I've instantiated my array with an initializer list. We could have also done this on one line, which you'll see a lot. Okay. We could have just simply said int bracket stones equals, and then, oh, wait, yeah. All right. 3, 1, 5. Okay. And we could have all just done that on one line. Okay. There is another way to declare and instantiate. So I'm gonna switch again. So I'm gonna go back to the slide so you can see that. And we can look at a general way to instantiate. So if you are on the slide presentation, we are on clip. That was a sample. Okay, so here's in general what you're doing. And I put an example for JavaScript and an example for Java here. So in JavaScript, you don't have to put the data type. You just put the keyword var for variable, representative variable. You have what your array name is. So my array name was stones. And then when you do its initializer list, you actually use brackets instead of braces, as you notice that you do in Java. But the second way that you can declare and instantiate is using the new keyword. Okay. And somebody mentioned some other type of elements you can use. Yeah, besides just primitive data types, you can use objects as elements in arrays as well. Okay. I just peeped over. I don't know what the beginning of the conversation was, but I just kind of peeped over in the chat.
That was the beginning.
Okay. All right. So then the way that you would use the new keyword is in Java, talking about Java, you would put the type again, brackets, the array name. So mine was stones equals new int, because my data type was int, bracket, and then the size of your array, or what we're going to learn later is called the length. So how many elements? You know, I like to use the mathematical term cardinality. You know, that just sounds good coming off the tongue. What is the cardinality of the set? Okay. And then to assign it, so my first element would have be in 0 position. So stones bracket 0 will equal my first element, so forth and so on. So it starts at 0. And it reminds me of when we were in Philadelphia playing some outside games, you know, jump rope, a tag or something. If you wanted to go first, you know, somebody might holler, "Oh, I'm first. And then somebody else might holler, "No, I'm 0, no higher." So whoever said 0, no higher, they went first. Mm-hmm. So it just kind of reminds me of that. All right. So the next thing we're going to do is talk about the vocabulary word dimensions. Okay. So what is the dimension of your array? So right now, you know, I had 1 row covered up, so I'm only showing 1 row, but I have 6 positions or 6 placeholders. So the dimensions of my array is 1 by 6. You know, so you write down, well, what is the dimension of your array? And I'll flip back to the thing. I'm probably going to erase this as I go. I don't know. Can y'all see that? No. Yeah. All right. So dimension is a 1 by 6 for me. You know, you write down, well, what is the dimension of your array? Okay. One thing, if I wanted to, the next thing is to find out, well, if the dimension of your array is 1 by 6, you have 6 placeholders, or the number of elements you have is 6. Well, guess what? That actually helps us with another vocabulary word. Okay. The other vocabulary word is something called length. All right. So then I will ask you, well, what is the length of your array? Well, if the dimensions of my array is a 1 by 6, then the length of my array actually is 6. It's the cardinality of my array. Okay. The way, how do we access this? Or how do we use the length in code or in syntax when we get to it? Okay. The way we do that is whatever the name of the array is, and you can see this on the slide in general, you'll have array name.length. So the name of my array is stones. So stones.length. Anytime I use this in my code, I'm actually using the value 6 for this particular sample. Okay, so the length of my array is 6, and when I want to use that in the code, I will put stones.length. Okay.
They can't see the document cam.
Oh, ooh, sorry. You know what? I still have my slides.
No worries.
God, I told you I was gonna have to be toggling between different things. So let's see. Application window. Thank you.
Perfect.
Okay. So yeah. So I just added 3 lines. I added the dimension line, the length line, and the stones.length line. And I'll tell you just a little side note, and I'm hoping not taking up too much time. I'm trying to go through. But these portable or personal dry erase boards, yeah, they'll come in handy in your classroom. Get a classroom set. You can get everybody involved at the same time. You tell them, okay, write it down. Okay, now everybody hang yours up and look around the room. So, there's a lot of different usage you can have for these. So I would say definitely try to invest or use maybe some of your CTAE money or department money, invest in some dry erase boards. All right. So moving right along. Okay. All right. Okay. So I've used this word already, but to talk about, well, what is the index? Okay. I've been saying words like position. You might hear the word subscript, or what have you. Okay. But what is that? Because that's really, really important, especially when you're trying to get to what we're going to do a little bit later, which is traverse the array. And then that's really where the real meat is, But yeah, under your manipulative, this is what I want you to do. If you have a piece of paper, or you have some sticky notes or Post-it tabs or what have you, go ahead and make four rows. So however many elements you have, you're going to have a spot for those number of elements plus one more. Okay. And I'll show you what I want you to do. All right. The labels of the rows, not the columns, the label of the rows are going to be ordinal, index, element access, and element value. Okay, so ordinal, index, element access, and element value. All right, so I'm gonna erase all these and see if I can write it on my erase board. I did have sticky notes as well. So, switch to, I hope you all have that. So remember, ordinal, index, ordinal, index, element access, and element value. Switch. All right. I'm like some of the other presenters with the sound effects. Start beatboxing on here. Okay. So we said ordinal. Okay. We had did you just mute yourself?
Yeah. So you
Okay.
don't hear all my clicks.
I'm trying to make sure that we're wrong. Index, element access, and excuse my handwriting, and what do you say, value? All right, element value. I'm gonna just put value. Okay. The ordinal, of course, deals with the order in which your elements are. So here I have my first element, second element, third element, fourth element, fifth. Okay, and literally is sixth, but I'm gonna just put last. Because sometimes we have to start from the endpoint and go, in reverse order, or sometimes we just need whatever that last value is. We need to do something or manipulate that last value. Okay, so the index deals with position, and I think we already stated that the index is 0. Did somebody have a nice comment they can interject or question that they had?
Yeah, Laura just wanted to remind everyone that indexing in math versus CS is different. But the indexing start with 0 versus 1 in CS versus math, respectively.
All right. Thank you very much, Laura. And I've been in several sessions with Ms. Laura Gray, so I know she knows what she's talking about. So thank you.
Yeah, she's on it. She's on it. Oh,
all right.
Kevin brought up a great point. Unless it's the CSP exam. Another caveat.
Oh, wow. So yeah, just make sure you identify, what subject you're doing at that particular time. So, and hopefully the students don't get too confused trying to go back and forth. Because I had a student, but I know teachers who have students that are in CSP and CSA. I'm like, at the same time? Okay. Go ahead.
Yeah, it's funny. The curriculum, the whole year you're teaching them the index starts with 0, and then you get to the exam. Oh, don't forget this pseudocode that College Board has.
Wow. All right. So then how do we use the element or access the array when we're dealing with our code, our syntax, so forth and so on? Well, the first thing we said is you can use the name of the array. You don't have to use 15 different variable names or anything like that. So the name of my array was stones, and it was like, I'm running out of ink already. All right, so I'm gonna try to toggle my writing. So stones, to get to my first element, or the element that's in ordinal 1 or position 0 or index 0, is the name of my array, bracket 0. Okay, and that's going to represent my first element. My next element is going to be stones. And this all should be on, if I had enough room, it would be on one line. Like I said, I'm just kind of toggle back and forth, isolate back and forth, and then keep going. So I want you to go ahead and do the same thing if you haven't done so already. Kind of keep going on. Whew, man, can't even understand what I'm writing. What is this? Sorry, I thought I had some thin markers that I hadn't used yet, but I couldn't find them. Okay, so if you see that a little bit, then I have stones 0, stones 1, stones 2, all the way up to stones the length of my array minus 1. So you want to kind of get them used to that language as well. Okay, the length of my array minus 1. All right. And then my values, once again, 6, 1, 3, 1, 2, 4, 5. Okay. So one thing you also want to make sure is that the students understand the difference between, especially if you have numeric values, the difference between the values themselves, the element values, and the elements index. The element values and the elements index. It could get real. Oh, I think that confusion was for something else, but it could get real confusing. I was about to say it could get confusing too. Okay. All right. So we have done a few things. We've talked about index, talked about length. ways to access the elements in an array. Um, we talked about the values and how to use the values and the array. So and coding and things like that. So my next task for you is, now that you have this, because a lot of students are visual learners, and if they weren't, they are now with their cell phones and things like that. But now they get to see physically in front of them, okay, with their items, manipulatives, and get to see in writing. Okay, well, how does this match up with what's in front of me? How does this match up with what's in front of me? I want you to go ahead and write down what is the element located at index 1, index 2, and index length, your array length. Okay? So I want you to do that now. I'm going to go ahead and just try to share the PowerPoint again so you can see what I'm asking. I already passed this slide. I told you I'm toggling between like 3-4 different screens.
You're good.
Okay, so what is your what is the element at index 1? What is the element at index 2? What is the element at index length? All right, hopefully you had a chance to just kind of look. Okay, what did you notice anything strange about the third question? Oh, I didn't see any. Okay, here you go. Okay, yeah, I see it. And I think somebody was talking about it earlier in the chat too, but I don't know what the beginning of that conversation was. Okay, so the third question really would throw an error, an out of bounds error. So if I was to show my screen again, my document tab. Okay, remember the example in the slides is different because I'm doing a live demo right now. That was just a live demo when I did the slides. There you go. Okay, so of course I know stones 1 is 6. I know stones 2 is going to give me the value of 1 in my example. However, if I'm trying to find stones, the length, remember, the length of my array is 6. So if I'm trying to find stones 6, I'm looking through the array, right? I just dropped my pen, kind of like a drummer dropped his stick, which he should never do. I should never drop my pen. Martial artist dropping his sword. Okay, all right. I don't see index 6. Okay, and a lot of times you'll find that some of your students might put that there by accident when they're trying to do some of their code, but just kind of remind them and get them to see, okay, remember when we did the unplugged activity, blase, boom, shakalaka. Okay, so all right, moving to the next thing. I want to take up. It's already 150. Okay, I want to get to the traversing part. All right. So the next thing would be, okay, well, I know we can't change the size of our array in Java, okay, but what if we wanted to replace some of the elements in Java in the array? Then we actually could. So if you have your manipulative, go ahead and at index 2, which is the third element, right? But it's index 2. Go ahead and change that value some kind of way. So if you have numeric values there, you can add, you can subtract or whatever. If you have objects there, you can change the object or change string or something like that. Just go ahead and change that value. I'm going to grab some stuff. All right. So what I can do, even though when I first called, so this is old. I might have to erase some things. So when I first called stones bracket 2, I would get the value of 1. Okay? But now, if I want to overwrite it, or now that I've changed it, if I call Stone's bracket 2 from here on out, from henceforth, for my literature arts people, okay, it's no longer 1. Okay, it actually takes on that new value, which is 4. So now every time I use Stone's bracket 2, we'll go ahead, it'll have a value of 4. Okay? All right. So I think we're about to get to the good stuff and then get to the gooder stuff. I know that's not correct. I'm just coining that term, gooder. Okay, no. With my partner Terry. Let's see what is next on the slides. Okay, so this was the sample out of bounds. Here you got a new. Hey, that's interesting. Oh, that's real interesting. I wonder with the same values in this sample and the new sample. Okay, so what we want to do now is go ahead and try to traverse or do something with every single element in the array. Okay, so if you have numeric values as your array elements, what I want you to do is just simply find the sum of all of those elements. If you have, let's say, something like characters or strings, string literals, go ahead and see if you can kind of put them together in a certain way. Okay. If you have other type objects, I don't know, you kind of own your own for right now because that's for another presentation. Okay. So go ahead and just kind of add them up or put them together or do something where you are manipulating every single element in that array. Okay. Then the thing I want you to do after you do that is just talk about or write down, just some quick notes, jot down some pseudocode or whatever. Like, how did you do that? Like, what were the steps you actually used? What was the procedure you used to find a sum or put those elements together or manipulate every single element? Okay. So I'll give you just a few seconds to kind of do that. Depending on, there's kind of multi-step, using different types of control structures. You can think about algorithms or what have you, try to get the students to connect back to when you covered the algorithm unit, especially in the CSP, computer science principles, or what have you. Okay, so hopefully you kind of doing a lot. Are we doing okay? Are you all kind of following along with us and doing some of the activities as well?
Oh yeah, there's a combination of that and some side discussions about it.
Yeah, because I'm like,
it's good.
Let me not look at the chat because I'm gonna start just confusing myself. I gotta look at the chat a little bit later. Okay, so just to kind of move on because of time. And this is kind of what I looked at, check to see if my array was empty or not. So it wasn't, had to get a counter to kind of where I can assign a running total as I was kind of traversing the array. One way, and I meant to ask you this question, but I see somebody posted it anyway. So it's okay. Because I was going to ask you, well, how do you think, what type of computer science concept do you think you can use to traverse an array? But I see that Brandon Murray went ahead and put in a for loop. So that's the answer. Yeah, Brandon Murray. Wasn't it your birthday yesterday?
It was.
I think yeah. So he's been doing it Monday, Tuesday, and Wednesday. So yeah. All right. So yeah, so you kind of traverse. And how am I traversing it? I'm going to traverse it by the indices in the array. So I'm going to start with the first element, but that first element's index is 0. So, in Java, and I'm using Java that you see on the screen. So I have to declare, well, I is going to be an integer, and it's going to start with the index 0, and then I'm going to go all the way up to, but not including the length of my array. So remember earlier in the presentation, we said to access that length, you put the name of the array dot length. You could have also written I is less than or equal to stones.length -1, okay? Because that comes in handy a lot as well, that -1, so you don't, get out of bounds errors and things like that. And then I'm going to increment by one position or one index number each time. And then each time, whatever that element is, so I have the name of my array and the index, whatever that current index is, that's what I is representing, okay, during that iteration of the loop. I'm going to go ahead and add it to whatever the previous value of sum was, okay? But then, so I'm gonna add it to the previous value of sum. And then at the end, after I've gone through all my iterations, here I should have 6 iterations for my loop because the length is 6. Then I'm going to return what that last value is of sum, okay? All right, so for the sample here, it was just 23, not the live sample, but the sample that's on this screen. And then, so here, I'm gonna click on a link, and then I'm gonna kind of just quickly, I'm not gonna click on the link for all the others, but we had a Code HS session and wanted to show you all just a code correspondence, if you wanted to see that. Chrome tab, I think. Here you go. Okay, so there's a link in the presentation. You have a link in the presentation up at the top of the chat, so you can kind of go back and peruse these yourselves. I would suggest, as your students are doing coding, that you strongly encourage them or make it mandatory that they document their program, that they use comments in their program and things like that. So you can kind of read through that. And if you run it, you'll see that it kind of adds up. And this corresponds to the sample that's in the PowerPoint presentation. So I'm gonna go back there so I can finish up and let my partner, Terry, go. I apologize, Terry. I'm trying to get through it.
Good. My part is really fast.
Okay. All right. So here in general is a way to loop through an array using a for loop. You have whatever those functions or manipulations you're going to do, just go in the body of the loop. This is another example using floating point decimals, negative values. Here's another example, which the link is in the presentation, where if you want to use strings, so I'll put them together or concatenated them. So it says it just made one long statement. Hi, my name is Sababu. So on and so on. And then 2D arrays. Somebody mentioned earlier in the chat that they like to teach 2D arrays. Well, that's fun too. So my Mancala board actually is a 2D array. And if we had time, I would actually do the same activities we did with a 1-dimensional array with a 2D array. But we don't have time today. You can definitely go back and look at the PowerPoint slide and see if you can kind of follow along with that. But the dimensions of my 2D array will be a 2x6 because it's row major. Some other things that we would do with a 2D array is about the indices, the indexing. So the indexing of a 2D array is the column, the row first, and then the column. Okay. I'm gonna go back to the PowerPoint slide, and then I'm gonna be done. I'm gonna be done for real. You're
getting some good shout outs from Brandon Murray.
Hey, thank you. So the one thing to remember about multi-dimensional arrays they are arrays of arrays of arrays of arrays of arrays of arrays. So 2-dimensional arrays are an array of arrays. So in an outer array, its elements are arrays themselves. So with my Mancala board, I would have an array with 2 elements because it's 2 rows, and then those rows would be arrays themselves. So one of the other things besides just finding the index of a two-dimensional array that we would have gone through is we would have actually traversed the two-dimensional array, and that's just locating the element using the index. So this is index row 1, column 2, which is the second row and the third column element, okay? And then I had an example of traversing the array. And if you click on the link, you'll actually see that when you're trying to traverse a two-dimensional array, just like we did a for loop or some type of loop, you could have used an enhanced for loop for a one-dimensional array. To do a two-dimensional array, you would have to use nested loops. That's why I said you should have covered control structures by then, and definitely, hopefully, nested loops by then as well. And I think that, and that's just in general how to do a nested loop. If you think about it as rows and columns, otherwise think about it as if you have a set of actions, that's the inner loop. And if you want to repeat those set of actions, that's the outer loop. That's kind of how I try to explain it to the students or the teachers, and then that's just another example. All right, Terry.
Well, there was a question from Helen about using the for each method in the last example.
Okay, I'm sorry. Go back.
Oh, correct, Laura. He does have it on the slide.
Which one is it? This one? Try to see if I can bring it up. Okay, and actually, that's not showing everything. Was it in the code? Was it the slide or the code sample itself?
I'm not sure if I got the timing of her question where you were when she asked the question. On the slide, I think. It's under when you were going over traversing on the slide.
Okay. All right. Can y'all see that?
Yes.
All right. And okay. So on here on line, I'm trying to pull it back on my other screen because I can't even see that. Array sum 2. Okay. So here I have a for each on line 29. This is a array sum 2. If you all are looking at the same link. So for each, okay. So E represents some type of variable, but opposed to the regular for loop where, if we use the variable I or whatever, that kind of represents the index. Here, whatever variable you're using here is going to represent the element. Okay, so not the index, but here E colon stones represents the array. So for each element, and I just use, when you're doing naming conventions, you try to associate it with what it represents. For each element in the array stones, I want you to go ahead and print out stones. Or you could do for each, up here, I could have done the same thing. For each element in the array stones, I could have said sum plus equals E instead of array, array bracket I. Okay, I hope that answered your question. But I have some other examples where that is, okay, good, I can see that. Where on my array string enhanced for loop, I have some lines that are commented out that represent the enhanced for loop. So like line 15 is the start of it, line 19 is part of it, as well as line 22. That will be all for the enhanced for loop. Okay, Terry, go ahead. Man.
Excellent. Thank you, Sababu. Excellent. I'll go ahead and share now.
Okay, and let me stop sharing. There you go. Okay.
How's that? All right. So So Abu just went over some unplugged activities or an unplugged activity for teaching arrays. And as you all know, students really love when you integrate physical computing into your CS curriculum. So today we're going to talk about using the Hummingbird kits for our physical computing. Let's see. So what are the HKits? They are Hummingbird robotics kits. They usually comprise of lights and sensors and motors. Students usually use these to make robots out of them. You can program them using multiple programming languages. The unfortunate thing about them, they are a little costly, but we will talk about some opportunities at the end of this presentation on maybe looking into GoFundMe campaigns and some other things that might help subsidize the price of these kits. So this is what a kit looks like for those. Actually, before I even begin getting deep into this, how many of you have used these Hummingbird kits before? I see PK is saying WordBrain is the bomb. WordBrain is the manufacturer. Okay, negative. Look slick, yeah. They are slick. They can be a little temperamental, but they are slick. Did not generate. Oh, okay. He's sometimes. All right. So, with that being said, so again, you can program them using ScratchX, MakeBlock, Python, Java, App Inventor, Arduino, Raspberry Pi. And so, typically, when we introduce these these components, these devices, we want to use some type of real world scenario to activate the lesson. And so with the Hummingbird kits, since they come with LED lights, it's just natural to use a traffic light scenario as you're warming up or as you're activating scenario. So using an array or list, create an algorithm that starts a traffic light sequence after 10 cars have passed through a given intersection. So this particular kit that I have has, and I'll go back one, it has the LED lights, the tricolor lights, a light sensor, I believe a temperature sensor as well, but we'll be using the light sensor to kind of check for whenever a car passes by. So I'll use my hand as the car every time I pass by and change the value of the light. It's going to add that car into an array, or that a car went by into an array. Because Big Brother's always watching, we'll also have it get like the license plate of the car and put it in an array for later uses or whatever. All right, so that being said, let's skip up to, so in order to use these kits with Blockbase, you would need to download the Hummingbird Connection app. It's a Chrome extension. It is free, obviously. It works very well. When you download this extension and open it up, it looks very much like Scratch, but it is an API that Hummingbird created specifically so that you can use the Scratch environment to program these kits. So, and this is kind of like what some of the code looks like. So again, it looks very similar to Scratch. So I'm going to share my other screen here. Let's see where it stopped. And let's share the code.
I'm just having fun reading through the chat. I had to scroll all the way back up to the top.
Oh, so fully missed the whole presentation, no problem. Okay, so I have this algorithm that I created that, again, once I run my hand over the light to kind of mimic a car going by, the sensor, your Scratch is about a great job, to kind of record every time a car goes by. And then once 10 cars have gone by, my traffic light sequence will start. So let's hope that this works, because it has been very temperamental today. But we're going to give it a shot. I'm going to also move my camera so that you can see the lights kind of light up. Okay, you can see we good to go there. So I'll move this here. It'll focus in a second. How's that? Is that good? All right, so I'm going to run my program. And so, oops, not it. Let's try that again. Uh-oh. I'm not even moving my hand over, it's already recording. So what's supposed to happen is, and I'll unplug it and start over again. It's going to give me a kind of like a benchmark of what my light value is, the light sensor value is. And once I put my hand over the light sensor to kind of darken it, it should start then accumulating some random, what I call random license plate numbers. I just picked some numbers in my random function here and added it to my cars list. And then once the length of that cars list is greater than 10, start my sequence. So let's try that one more time. And unfortunately, the light sensor is not working, but if you notice, and the lights have not turned on as well. Let me just try that one more time. Apologize. Okay. It has been very temperamental all day. Okay, so let's start that over. I'll take off this block for now. Let's just see if my light sensor is working. It is not. Okay, well, at any rate, what's supposed to happen is, again, every time I move my hand over this sensor like that, it would add to my list. And then once that list is greater than 10, my sequence of a traffic light would start up. No, I don't have my idle program open. Very good question, PK, because I'm also going to show you an example of this in Python, but I don't have idle open at this moment. I checked for that. Let's try it one more time before I give up. You'll have to tell your students they have to be very patient when it comes to physical computing. I think I have Mr. Guy in this session. He's one of the teachers that we work with. And we spent probably a day and a half just troubleshooting getting the devices to work, to connect before we can even program them. So you do have to have some patience when it comes to these devices. All right, let's try one more time. Oh, well, I can see right here, I have a yellow light. So if you go to more blocks, this light is yellow. So it's telling me now that it's not connected. So I'm going to restart the whole program. Give me 1 second here, I'll refresh. And then I'll import the file that I have. Still no green light. One more time. Now, of course, before this, oh, there we go. Before the session started, I did it like 3 times just to make sure we were good and it was working. And as soon as the session starts, like, nope. All right, so let's try it out now. So I'm just going to double check that my sensor. Yep. So right now, without my hand being over the sensor light, the value is 13. So I kind of use that to test out the sensor before I even begin. And if I put my hand over the sensor, let's see if it changes. It is not. Okay. Oh, there you go. All right, well, let's try the Python one, and maybe we'll come back to this one. With the Python example, there will be, yeah, live debugging, exactly. There will be opportunity for you all as participants to submit your sequence to change what I already have. So I'm going to give you this link to a shared drive that we have, shared folder. Let me stop sharing for 1 second. Yeah, it probably is a hardware problem, Rich. So let me give you guys this link. So if you click on this link, there is a folder that has the Python file. While I'm getting this ready, if you all could please download idle, if you don't already have it downloaded on your machines. This is the link to the Python file that I have. So I'm going to show you an example of a very similar code to what we had in ScratchX. I did it in Python, and it seemed to work just fine. But I'm going to allow you all to kind of engage in this activity and change a part of that code, the sequencing of the lights part of the code. And then if you upload the file into that drive, that folder I just gave you access to, I will run it in idle on my side so that you can see what your sequence looks like. So let me get idle open.
What got you interested in using and getting into physical computing?
Okay, so I think when I went through, I think I went to a Barb Erickson workshop way back in the day when she was at Georgia Tech, and she was explaining the importance of incorporating physical computing in your CS curriculum. And so at the time, I think she had like Lego Redos and maybe some benches. I think there was something else I can't remember. Oh, and EV3s, obviously. And so that kind of inspired me to always have some type of physical computing component in one or two of the units, at least. Some units lend itself to physical computing science, physical computing better than others. And so we usually use it in the beginning just to get the juices flowing, get everyone activated and excited. So that's kind of what got me into them. And I'm always looking for newer toys. This particular one, Hummingbird Kits, PK Graf, who's actually in the session, he introduced these to us a few years ago, and we fell in love with them. Okay, so give me a thumbs up or just let us know, were you all able to download idle at all? Do you need links to idle? Yes, agree, Rich. Please send the link if you can, okay? So this is the link for idle.
Hello, school system PCs. Don't let people install anything.
Oh, they're not able to install? Okay, well, I'll demo first, and then for those that can install, we'll go from there. All right, so open recent files, okay. So this is the code that I have, and I'll share my screen here, my application. All right, can everyone see that? So this is what I created for the Python example. Similar concept. And let's see if it works. Right, so I'm going to unplug and reset. Does not want to cooperate today. What a bummer. Oh, green light. Okay, let's try it again. Nope. Well, I apologize for that, you all. Yeah, again, yes, everything's plugged in. I apologize for that. Unfortunately, we're having technical difficulties with the kits. But I will, what I'll do to kind of supplement this, I will record what we did to set this up. I will record it working so that you all can see it. That's true, Rich. Actually, last night when I was playing with this, I accidentally put it in the infinite loop and it did get fried. So I had to get another one. But yeah, so the hardware seems to not be responding, unfortunately. So what I will do though, I have a spare. I'll do a recording. Oh, you want to try to run it, PK? All right, we'll try to run it on PK's machine. Do you want to use this one or do you want to use the one that writes to the file? We're going to try to see if PK. Okay, we're going to see if PK can run his. So I'll give you access to share, PK. Yes, teamwork makes the dream work.
What's up? Hopefully y'all can hear me.
Yes, you sound good, man. What's up?
A little impromptu, so I'm glad I was here so I can jump in and help. I'm going to share a window with y'all.
PK is not from New York.
What's that? Okay, all right. Let's see here.
Elena, it could disable it. At the least, it'll fry it. Again, I had to use a spare kit today because I accidentally ran an infinite loop last night testing this out. So, yeah. This one is a new one, and I just had it working maybe 30 minutes before we got on, and yeah.
All right, so Terry, this session was the about arrays, and Terry and I were working on some programs last night and jamming on some different stuff. So I actually made some modification to this. Let me change it real quick, change it back. But the goal was to use these awesome physical computing devices to reinforce how we need arrays in computer science. And so I wrote this program a while back and made some modifications to it. So basically what this is going to do is it's going to use a Hummingbird to log the light values from the light sensor. And then it's going to use the LEDs and the vibration motor to confirm to the user that a sensor data point has been logged. And so when I run the module, if you listen, you can hear the vibration motor and the LEDs lighting up. And in the console, we get a log of a bunch of strings that were put together to create a data log. But then at the bottom, we get this nice array. And how many dimensions is this array? Anybody?
It's very small, so I don't
It's
know.
very small.
Yeah.
So in Python, this is a list. And so talking to the students about the differences in the lingo between the different languages, but essentially we can rely on that same, the same output being referred to in different ways in different languages. So before we were looking at Java and JavaScript, and here looking at this in Python. So Does that help, Terry? Is there anything else you want me to hit on?
No,
here?
that was it. I mean, I really wanted to allow them to be able to submit a few examples of the file that I had, left some room for them to kind of manipulate the sequence, but they want you to show the code. So can you zoom in a little bit?
Yeah, let's see. I don't, options, can I make this bigger? I guess I have to go into the settings, right?
Yeah. Or if you want that file, that shared drive that I put on the chat, if you can just drop
I can put this in there for sure.
Yeah.
Let's see, window, zoom. Oh, does that help at all? No, show the code.
Not really.
Sorry.
It's all good. Yeah, just drop that Python file out of the drive.
Yep, will do.
Hey, PK, one more thing. Introduce yourself so that people know who you are.
No, I did not. Well, let me finish that thought really quick. One cool thing about this program, it's a necessary topic, or I think it may be even a learning objective across the board in computing courses, input and output, as well as data. So this program is using input from the environment to create outputs, but then it's also outputting a file, which is really cool that I did not mention. So it drops all of the data into a text file, and you can drop it into a CSV file as well. And I just remembered that I forgot to add the line of code to print the to actually send the array or the list to this as well. But neither here nor there. So yes, introducing myself after talking for several minutes. I'm PK Graff. I am a STEM content specialist for Forsyth County Schools. I specifically work within the Academies of Creative Education. And Terry and I were the first two fellows with Constellations. And I joke, and it's been a while since we made the joke, but I think Terry actually is the first fellow by like 3 minutes.
3 minutes.
He sat down with HR before I did, but we were there on the same day. And I remember it was like two little kids on the first day of school when we met. It was hilarious. So, yeah, that's me.
I appreciate that save, PK. Again, for those that are very curious on seeing this work in action, I will personally do this week. I will make a video, record my screen, record the physical computing going on, and then have that uploaded to our Constellations website before the end of this week. I promise you.
Okay. All right. There was a question, PK. Do you know Ahmad Baruka? I'm probably saying the name wrong.
That name looked very familiar.
So before we conclude, oh, you were a mentor teacher.
Hey. Okay.
Yeah, and David, the Hummingbird website does have tons of lessons and projects and stuff. It's definitely a great place to start.
Before we conclude, are there any questions on what we did today as far as the resources? Oh, and I don't think I showed you all the last slide.
Right. Yeah, that's what I was going to try to get to.
Yeah, you want to pull that up on the...
This.
Close out. I'll stop.
And I'll say peace.
Thanks again.
Y'all take it easy.
All right. Appreciate you. Okay. All right. Got to pull it up. Okay. So we are two of the three fellows Constellation Center, but the third fellow, Ms. Yolanda Payne, which you've seen in moderating some of the sessions, actually contributed to this presentation as well. So here, these are just some of the standards that align with the College Board for CSP, CSA, and the slides, Code HS, which is one of the platforms that we encourage people to use, CSTA, so forth and so on. If you know any other resources and links where people can learn about Java or arrays, please post them in the chat as well. That'd be very beneficial. But then here are some links, a couple of institutions that can help you in the classroom. Donors Choose can help you get funding for projects. All you do is kind of go to their website and tell them what type of projects you're trying to do in your classroom with the students. And, that's a way to raise money so that you can go ahead and do those projects. If you need materials, software, equipment, so forth and so on. And then another resource is the Civil Air Patrol STEM kits that, you go to their website and they can send you some kits and materials that you can use for your school. So with the Donors Choose, they also have a match. Sometimes different corporations can match what you've raised so far, and you can double your money. So that's pretty good. Both programs are available to teachers. For Donors Choose, teachers must submit a project, and funding is crowdsourced. Civil Air Patrol membership is $35, but that's for lifetime membership. So that's not even every year. And then STEM kits are given to teachers in return for just a short report and pictures of you and the students using the materials. Okay, and then this is a way to contact us and stay connected. Constellations.georgiatech.edu, email gtconstellations@georgiatech.edu. That's where you will send your attendance inquiries, and please make sure you fill out our attendance form. Twitter, follow us at Twitter at GT_CCEC. Instagram, the same at GT_CCEC. If you took screenshots and pictures, and especially pictures of yourself doing the activities, we would love to see them. Please post them to social media and tag #Constellation Summit. Okay, it was great having you all here. I enjoyed it. I'm a little calm now because my heart was racing while I was doing the presentation.
It's all family, man. Again, I apologize for the technical issues, but I will make it up to you, I promise.
Okay. Let me see. Can we just repost the attendance just in case?
Yes, form? I will do that right now.
So yeah, we thank you for coming. And if you have any questions, they hang around for like 2 more minutes or so. Please ask your questions. I see some resources coming through. Attendance form. See it. But don't forget, if you got some resources that you use to demonstrate arrays, please share them.
Yeah, you can actually use that same shared folder. If you want to drop anything in there, I think I gave you all rights. I'll put that drive, a link to the drive on here again.
I guess I can stop sharing now.
What have you guys found to be some of the most successful ways to success parts of tech like this? I would say probably Donors Choose. If you write it up the correct way, you pretty much can get funding. You want to put that slide back up. I would also, Yolanda's about to chime in. Yay, Yolanda. Yolanda is like the expert on securing funds for all CS related activities or resources. Yolanda, you want to speak on some resources that some of these teachers can look into about getting funding for equipment?
So I got in right at the right time, huh? So 2 of the major sources that I used when I was in the classroom was Donors Choose and the Civil Air STEM kits. But with Donors Choose, one of the things that people overlook a lot of times is the match offer. So I know they talked about that, but really look at your state and see, because some days you can put up a project and they fund all the books on the site, or some days they'll fund all the tech on the site. With the Civil Air Patrol, same thing. You just it's a minimal investment for a big return. And then one of the other things that I did, I asked businesses in the area if they would donate to my classroom. If a parent was worked somewhere, asked if they have any grants. There's just a lot of funds out there that teachers don't often have the time to pursue, but you'd be surprised at how many people are willing to give you money. And if you need any help, I'll put this out there for the people watching. If you need any help, feel free getting one of those projects started. Feel free to reach out to me. And I've written up quite a few, got a lot of stuff for classes, so I'd be willing to help you.
Okay, and one resource that was shared was check your local RESA, check for district level initiatives and things like that.
And there's also some local universities. Did you mention local universities who have loaner programs?
Oh, no, I didn't.
Yeah, some of your local universities may have loaner programs. I know Bird Brain actually, I think, also has a loaner program. So yeah, if you want to look into some of your local universities or colleges and see if they have any loaner programs with their equipment. I know Georgia Tech in the beginning did a lot of that before folks got their own program going. They had a loaner, and I think they still do have a loaner program. So if you're around Atlanta, you can check with Georgia Tech, check with us.
All right. Any other sources or questions?
Great point, PK, about talking to your principal. Yep.
Yeah, PK came to the rescue. You missed it.
Yeah, my kit died on me. We had to share a screen. This has been the day of technical difficulties. I tell you, we've had like 3 sessions like this so far.
Thank God for PK. See, we need you. Social emotional learning, SEL. So that's about.
Yeah. Anything else?
Are we at the stage or hold on? Let me check.
So there's a break until 2:45.
Okay.
And then it's at the stage. So glad I got a chance to say hi.
Thank you so much, Yolanda.
The gang's all here.
Perfect. I mean, dude, I don't know if you could hear us, but that was like perfect timing.
No, my session ended early, so I was like, let me check on my fellas.
Thank you so much, Brandon. That means a lot. We've been talking about you ever since yesterday, dude. You were bananas yesterday.
Ever since Monday.
Yeah,
because I was in a session with on Monday.
Yeah, I've heard from a lot of folks, including myself. I've said this. You made a lot of people want to step their games up. So, great job this week.
All right, I'm gonna.
All right, so yeah, I'm gonna go ahead and step out so I can get to the next session.
Okay.
And thank you all for coming.
Great job, Babu. Thank you, Yolanda.
Yeah, wonderful partners.
Bye. See y'all later.
Bye. You're welcome, Taylor.